So welcome to today's lesson, velocity time graphs. So by the end of the lesson, you should be able to interpret velocity time graphs, determine the acceleration from the gradient of a velocity time graph, and finally determine the distance traveled from the area between the velocity time graph and the time axis. So in terms of velocity time graphs, the slope or gradient of a velocity time graph represents the acceleration. And the steeper the gradient, the more the object is accelerating. If the gradient is horizontal or zero, it means that the object is traveling at constant velocity. And if the gradient is negative, it means the object is slowing down or decelerating. The area under a velocity time graph represents the total distance traveled. So for this example here, the total distance will be the area of a triangle, or half base times height. So to calculate the area, it would be half the time it takes to travel that distance multiplied by the velocity. So here's an example of it in action. So in terms of the object's motion, it begins to accelerate in section 1, and we can calculate the acceleration by taking the gradient, which is the change in y over the change in x, or 8 minus 0 divided by 20, or 0.4 meters per second per second. For the second portion of the object's travel, from 20 seconds onwards, it is horizontal, which means that the object is traveling at 0 meters per second in terms of its acceleration. The velocity is constant. For the final portion of the object's travel, you can see that it is a negative gradient. It is decelerating. And we can see that by the change in y over the change in x. So the final velocity minus the initial velocity is 0 minus 8, and you divide that by the time it took to travel that distance, which is 48 minus 42 seconds, or minus 8 divided by 6, or negative 1.3 meters per second per second. It's negative because the object is decelerating. In terms of the total distance traveled by the object, you can break down the area of the graph underneath the graph by breaking down the shapes. So you can see it's an area of a triangle plus the area of a rectangle plus the area of a triangle, which will be half times 20 times 8 for the first triangle, plus 42 minus 20 times 8 again for that area of the rectangle, and then the small triangle you can calculate as half times 6 because it's 48 minus 42 in terms of the base, times 8, which gives 24 meters. Okay, so the total area will be 80 meters plus 176 meters plus 24 meters. A total distance traveled of 280 meters.